Well, hi there. Today we're going to spend just a little bit of time talking about Lesson 99. Lesson 99 has to do with the Pythagorean Theorem. And the Pythagorean Theorem is a theorem that's reserved exclusively for right triangles. Let's first discuss what the Pythagorean Theorem is and what it does for us. Okay? The Pythagorean Theorem states that with right triangles, the square of the hypotenuse is equal to the sum of the squares of the two other sides. That's a good definition, needs to go in your notes because it's an important one and it helps you to remember why is it that I'm using the Pythagorean Theorem. Okay? This is what the Pythagorean Theorem looks like right here. Okay? Pythagorean Theorem says a squared plus b squared equals c squared. Now, what's A, B, and C? Well, we're going to know right now. Okay? Look at this picture. Okay. The hypotenuse is the side of the triangle that's directly opposite the right angle, or the 90-degree angle, right? This is 90 degrees. Okay? And the hypotenuse is directly opposite. We call the hypotenuse C. Now, there's two legs and a hypotenuse to every triangle. This side we will call A, and this is a leg, and this leg we will call B. So, it coordinates right with the Pythagorean Theorem. This side squared plus this side squared equals this squared. Not really too bad. Okay? Now, so let's try to prove some triangles as right triangles. We will use the Pythagorean Theorem to do that. First one to prove. Okay? So we have 4, 3, and 5. So 4 squared plus 5 squared equals 3 squared plus 4 squared equals 5 squared. There we go, we got it right. So 4 squared is 16, 3 squared is 9, 5 squared is 25. 16 plus 9 is 25. 25 does equal 25, so yes, this right triangle does fit the Pythagorean Theorem, so it definitely is a right triangle. Okay, let's check this one. Is it a right triangle? Here's the measurements. We have 4 squared. I usually go in order, smallest to largest, if I can't tell for sure where the right angle is. I'm guessing you might have a right angle here. That would be a guess. So this would be your hypotenuse. This would be your A, this would be your C, B, and this would be your C. So 4 squared plus 5 squared equals 6 squared. We're trying to see if it works for the right triangle. Alright, so 4 squared is 16, 5 squared is 25 plus 36. Uh-oh. 41 does not equal 36, and therefore it is not. It is not a right triangle. Even though it kind of looks like one right here, it is not. Because the Pythagorean Theorem says so. Okay? Let's look at another one. Is this one a Pythagorean Theorem? Or the right triangle? Using the Pythagorean Theorem, we're going to check it out. We have 7 squared, and 10. This is the longest one, so we'll call this A, we'll call this B, we'll call this C. Okay? So 7 squared plus 7 squared equals 10 squared. 7 squared is 49. So 49 plus 49, does that equal 10 squared, which is 100? Don't think so. 98 does not equal 100. So it is not a right triangle. In fact, it is an isosceles triangle because these two legs are the same length. So, okay, looking at another example. And again, you're going to see it right away, but we have 5, 12, and 13. So we set it up using Pythagorean Theorem. 5 squared plus 12 squared equals 13 squared. I go smallest to largest. 25 plus 144 equals 169. 13 squared is 169. Yay! Yes, this one is. Okay? If I was going to make a guess, I would guess this to be the right angle. Okay? Going down. We can also use the Pythagorean theorem to solve for missing sides in right triangles. For instance, here is a right triangle with a missing side. So this is our C because it's across from the right angle. And we'll use this as A and this is B. So 12 squared plus 9 squared. This is B, not 9, okay? And this C we don't know. So 144 plus 81 equals C squared. Add these two together, you get 225. Now to solve for this, you have to do something we maybe haven't done a lot of, but you have to take the square root. So if you take the square root of C squared, you get C, because C times C is C squared. Take the square root of 225. You might have to guess at this for a little bit, but it won't take you too long to figure it out. That 15 times 15 is 225, and therefore the length of C is 15. So 15m, because I think we're in meters here, is C. Okay? Now we're going to look at one more. I think we have two more examples. Yeah, okay. Two more examples. All right, so we have a missing side on this triangle. It is A, and then we have 24 and we have 26. So, and it is a right triangle because it's marked that way right here. Okay, so A squared we don't know. 24 squared equals 26 squared. So we go ahead and square 24 and we go ahead and square 26. So we end up with A squared plus 576 equals 676 because that's 26 squared. Subtract 576 from both sides and you end up with A squared equals 100. Square root of A squared is A. Square root of 100 is 10. Answer, A equals 10 millimeters. So this would be 10 millimeters, 24 millimeters, and 26 millimeters. This is B, this is C. Okay, one more example. Okay, we have this lovely drawing here, and sometimes triangles don't look like a right triangle because they're at an angle, but this one is, it's marked for you. So you have an 8, a 6, those are both legs. This across here is your hypotenuse, so that's your C. So this would be your A, this would be your B. Okay, so A is 8, B is 6. 6 squared plus 8 squared equals C squared. 36 plus 64 equals C squared. 100 equals C squared. Take the square root of 100, take the square root of C squared. You end up with 10 equals C. 10 inches equals C, and we're done. Now, that wasn't so tough, was it? Pythagorean theorem is a fun thing to do. And when you get into your upper level math classes and you're looking for a missing part on a triangle, if it's a right triangle, it is a zippity-doo-dah way, quick way to get it done. All right, thanks a lot. I hope you understood this, and I hope you have a great day. We'll talk to you later.